So we'll continue the question. So you are given the vector R which is xi plus yj plus zk, and the scalar R equal to root of x square plus y square plus z square. So before evaluating the gradients of each function, so first of all I will calculate what is dou r by dou x, dou r by dou y and dou r by dou z. So you have r equal to root of x square plus y square plus z square. Now if you square on both sides, you will get r square equal to x square plus y square plus z square, and differentiating with respect to x implicitly on both sides, so you are going to get, so r is a function of x, y and z, so you will have partial derivatives. So 2r, dou r by dou x will be equal to 2x, so that gives dou r by dou x equal to x by r. And similarly, if you differentiate with respect to y, you are going to obtain dou r by dou y equal to 2y by 2r, so which is y by r, and similarly dou r by dou z will be zr. Now we will be using this to evaluate the gradients. So first you have to find gradient of r. So by definition of gradient, that is I dou by dou x plus j dou by dou y plus k dou by dou z of r. So take so you will get dou r by dou x in the first component, dou r by dou y in the second component, and dou r by dou z in the third component. So substitute the value of each derivative. So you will get x by r I, y by r j plus z by r k. So r is common in all the terms, so you will get 1 by r. What is remaining is the vector r. So that will give vector r by r. And similarly in the second problem, gradient of 1 by r, so you need to evaluate dou by dou x of 1 by r, dou by dou y of 1 by r, and dou by dou z of 1 by r. So again by chain rule, the derivative is minus 1 by r square into dou r by dou x minus 1 by r square into dou r by dou y and minus 1 by r square into dou r by dou z. Now substitute for dou r by dou x, dou r by dou y and dou r by dou z. So this is what you are going to get. So which is, when you simplify, you will get minus of xi plus yj plus zk by rq. So that is minus vector r by rq. So which solves the second part. And third one, again similarly, you need to calculate gradient of r raised to n. So take the derivatives of r raised to n with respect to x, y and z. So with respect to x, you are going to get n into r raised to n minus 1 into dou r by dou x, and n into r raised to n minus 1 dou r by dou y, n into r raised to n minus 1 dou r by dou z. So substitute for the derivatives. So once you simplify, you will get n r raised to n minus 1 by r into xi plus yj plus zk. So this is the vector r, and this becomes n r raised to n minus 2 into r. So that is the third part. And then the last one, you have a constant vector. So let us define a equal to a1i plus a2j plus a3k, where a1, a2 and a3 are constants. Now I need to find the gradient of a dot r. So first find out a dot r. So r is xi plus yj plus zk. So a dot r becomes a1x plus a2y plus a3z. So when you take gradient of a dot r, so that is the gradient of this function. So when you differentiate with respect to x, we will get a1, with respect to y a2, and with respect to z a3. So that gives the vector final value as a1i a2j plus a3k, which is the vector a which you have taken. So del a dot r is equal to a. So we will finish off with this for the first class, and we'll continue with more problems in the next class.